Ratio and root tests. Video 3. In video 1, we introduced and proved the ratio test. In video 2, we gave examples. In video 3, we'll introduce and give examples of the root test. The statement of the root test is very similar to the statement of the ratio test. We define a row in a limit using the terms of the sequence. Here we're doing the nth root of the absolute value of the terms. And the three statements, three conclusions, are identical. The proof is very much related to the ratio test proof. Rho, being taken as a limit of terms, tells you that these terms are going to be very close to rho for sufficiently large n. Back off the nth root by raising each term to the power n, and the nth term is going to be very much like rho to the n. Then the next term after that will be like rho to the n plus 1, term after that, rho to the n plus 2, and so forth. As this is a geometric determined by rho, if rho is less than 1, we have convergence, which by the limit comparison test is going to imply that our series converges. Likewise, if rho is strictly bigger than 1. Likewise, the inconclusive part can also be established by looking at p-series. Beautiful. Let's do an example of applying the root test. When can you apply the root test? Well, you should have something to a power n. Now, when we did the ratio test, we were looking at powers of n being strong. So let's see how that plays out here. Very good. First, form up the nth root of the absolute value of an. And in the exponent, we simply have to remove the n's. Nice. Since letting n go to infinity, we're getting an indeterminate form. Let's use the limit notation. And using the limit notation, then it's very clear that L'Hopital's may be applied. This 2 will pop down, do a chain rule computation, ln appears to the power 1. Derivative of ln, 1 over n, but in the bottom, n differentiates to 1. We come up with a second indeterminate form, leading to a second application of L'Hopital's. 1 differentiates to 1, n differentiates to 1, and ln differentiates to 1 over n. This limits to 0. That is our value for rho, and 0 is less than 1. Therefore, we have absolute convergence. What test have we used? We're using the root test. Excellent.